Imagine you're sitting in a courtroom, right? And you are facing potentially years in prison for a single retweet.
Just one click.
Yeah, one click. Most lawyers would look at that situation and immediately start arguing intent. Like they'd say, oh, you didn't mean to cause harm, or maybe your thumb slipped while you were scrolling, you know.
Right, the usual subjective defenses.
Exactly. But today, we are looking at a case where one man decided to walk into a courtroom, completely bypass all of those traditional legal arguments, and just pull out the fundamental laws of complex network physics.
It is honestly one of the most staggering approaches to legal defense I have ever seen.
He used math to prove that the crime he was accused of was a physical impossibility.
Yeah, he basically stood up and told the court that their entire understanding of reality was out of date by about 3 centuries.
Which is just wow. And that audacious move is the mission of our deep dive today. I want to welcome you to the show. We are exploring this absolutely fascinating collision where fundamental human rights meet the absolute cutting edge of complex systems physics.
And we should mention that beautiful quote from the Universal Declaration of Human Rights right up front.
Oh, absolutely. All human beings are born free and equal in dignity and rights. Keep that in mind, because it's going to come back around in a major way later.
For sure.
So, the source material we are unpacking today is this highly technical legal defense document. It's titled The Prison Self-Defense and Blood Letter of Accusation.
Which is an incredibly intense title.
It really is. It was written by Dr. Chen Jingyuan. He was charged with, and I'm quoting the source here, picking quarrels and provoking trouble and causing serious public order chaos, all simply for forwarding or reposting some content on a social media platform online.
And that sets up this incredible intellectual showdown. On one hand, you have a local judicial system operating on very standard traditional legal definitions of cause and effect.
Right.
And on the other hand, you have a defendant armed with advanced mathematical theorems.
Now, before we really get into the physics of this, I need to make a very clear disclaimer up front. Our goal today isn't to litigate the politics of his original post, okay? We are not taking any political sides today whatsoever.
Definitely not.
Our mission is purely to impartially report on the sheer scientific and legal logic that Dr. Chen uses to defend himself in the original source material. We are not endorsing any viewpoints.
We're just looking at the math.
Exactly. We are just completely fascinated by how he uses structural physics to completely dismantle a legal accusation.
And the sources actually describe his defense as an epistemological dimensionality reduction attack.
Oh, what now?
Right. It's a mouthful. But he is basically arguing that you simply cannot apply 17th century mechanical linear legal logic,
Right.
Where A directly causes B to the 21st century reality of complex nonlinear digital networks.
Oh, I see. It's like trying to use the rules of checkers to penalize someone who's playing quantum chess.
That is a perfect way to put it.
Yeah.
Yes.
Okay, so to understand why Dr. Chen says he mathematically could not have caused this chaos, we first have to understand the baseline state of the internet itself.
Right. The environment where the quote-unquote crime happened.
Yeah. Because the law generally assumes that society defaults to order, right? Like everyone walks in a straight line. And therefore, chaos is this localized anomaly created by a bad actor.
But if you look at the actual architecture of the internet, science says the complete opposite.
So what is the baseline state then?
Well, the underlying physics of distributed systems simply do not allow for perfect synchronized order. And to prove that, Dr. Chen invokes something called the CAP theorem.
The CAP theorem.
Yes, CAP. It was proposed by a computer scientist named Eric Brewer back in 2000 and mathematically proven by Gilbert and Lynch in 2002. It's basically a foundational rule for any distributed data system.
Which is exactly what a global social media platform is, right? Because the data isn't just sitting on one giant computer in a basement somewhere.
Exactly. It is fractured across thousands of servers worldwide.
Okay, so what does CAP actually stand for?
It stands for consistency, availability, and partition tolerance. And the mathematical law states that in any distributed system, you can only guarantee 2 of those 3 properties at the exact same time.
Only 2.
Only 2. So consistency means every single server and every single user sees the exact same data at the exact same millisecond.
Okay, that makes sense.
Availability means the system always responds to your request no matter what. And partition tolerance means the system keeps operating even if the network gets fractured.
Like if a server goes down or an undersea cable gets cut or something.
Exactly.
Well, the internet is physically spread across the entire globe. Like connections drop all the time, routers fail, network traffic bottlenecks. So partition tolerance isn't really a choice, is it? It's a physical inevitability of the hardware.
You hit the nail on the head. Because networks inherently have partitions, system designers are forced into a rigid mathematical trade-off. They have to choose between guaranteeing consistency or guaranteeing availability.
Oh, wow. And modern social networks always choose availability, don't they?
Always. Think about it. The entire business model of a social platform relies on you opening the app and instantly being able to scroll a feed or see a post.
Right. If the platform waited to ensure every single server globally had perfectly synchronized the data before showing you a single tweet, the app would just constantly freeze.
It would be unusable.
Okay, let's unpack this because this is huge. If a system deliberately chooses availability, they are physically sacrificing consistency by design.
By design, yes.
That means local disorder or lag or inconsistency. Those are not bugs.
No, they're not.
They aren't anomalies. They are the actual physical, structural norms of the system itself.
And that is the core of his first argument. The baseline state of a social network is a state of constant, localized inconsistency.
It makes me think of a massive, bustling open-air market.
Right.
Like, everyone is shouting at once, people are haggling, prices fluctuate from stall to stall.
News travels through whispers that get distorted.
Yes, it is inherently noisy and chaotic. But the legal system seems to view society like a perfectly silent, synchronized marching band.
That's a great analogy.
In a marching band, if one person steps out of line, it ruins the entire formation. It's a highly visible anomaly.
And that perfectly illustrates the fundamental disconnect here. A market functions efficiently, specifically because it is a decentralized flow of chaotic interactions.
Right.
But the marching band requires a rigid central command. Social networks are open-air markets, not marching bands.
So if the system is mathematically built to be chaotic and somewhat disordered, prosecuting an individual for causing chaos is essentially a category error.
Exactly.
You are taking a structural reality of the digital environment and blaming it on a single user's microaction.
Dr. Chen frames it so beautifully. He argues the prosecution is observing the background noise of the CIP theorem at work, and they are mistaking it for criminal intent.
That's wild.
It would be like standing in a hurricane, pointing at one specific person exhaling and blaming their breath for the wind speed.
Wow. Okay, so structurally, the baseline is this engineered disorder. But that presents a bit of a paradox, doesn't it?
How so?
Well, if the system is just a sea of noise and inconsistency, how does any information actually travel? Because we know things do go viral. Massive cascades of information happen online all the time.
Right. And to understand that, we have to look at the physical shape of the network itself. How are those people in the open-air market actually connected to each other?
Okay.
Dr. Chen brings in this concept of scale-free networks. This was pioneered by physicists Barabasi and Albert.
Okay, so what does a scale-free network look like?
Well, if you map out human connections on a social platform, they do not look like a neat, evenly spaced highway grid where every intersection gets the same amount of traffic.
So we aren't talking about a democratic distribution of influence. It's not a situation where everyone has roughly 500 friends and an equal voice.
Not even close. Scale-free networks follow what physicists call a power law distribution.
Which means?
It means the vast majority of the influence is concentrated in a tiny fraction of the network. You have a few massive hub nodes.
Like celebrities or state media accounts.
Exactly. Massive influencers, algorithmic aggregators. They have millions of connections. But the overwhelming bulk of the network, the millions of everyday users, make up a long tail of what we call edge nodes or peripheral nodes.
Whispers compared to the megaphones.
Yes. And this structural inequality completely dictates how the network handles stress and damage.
How so?
Well, back in the early 2000s, a physicist named Cohen developed a critical threshold formula for these networks. He proved that scale-free networks are almost unnaturally robust against random failures.
Unnaturally robust.
Yeah. Because the system is mostly made up of disconnected edge nodes, you could randomly delete nearly 100% of them, and the network's overall structure would remain perfectly intact.
Wait, really? The information would just route around them using the hubs?
Exactly. The only way to actually break a scale-free network or cause systemic chaos is to target the hubs. The edge nodes are structurally irrelevant to the stability of the whole.
Wow. So, applying this directly to Dr. Ken's situation, we have to look at the metrics of his specific account.
Right.
The source text notes that he had fewer than 100 followers. Most of them were inactive, and he had practically zero historical interaction on his posts.
So structurally speaking, he is the ultimate edge node.
Yeah. Whether he posts, deletes his account, or drops offline entirely, it changes the geometry of the network by exactly 0%.
In the cold, hard physics of network topology, his capacity to disrupt the system is statistically approaching zero.
Here's where it gets really interesting, though, because I have to play devil's advocate for a second.
Go for it.
Even an edge node is still a node, right? The internet is highly unpredictable. Couldn't his one single retweet just happen to cross the feed of the right person, who then retweets it to a hub, and suddenly it snowballs into a massive catastrophic event?
Ah, you're touching on the butterfly effect.
Right. The butterfly flaps its wings in Brazil and sets off a tornado in Texas.
Which is exactly the implicit argument the prosecution is relying on. But complex system science doesn't operate on abstract what-ifs. It operates on measurable probabilities.
Okay.
To test that snowball theory, we have to move from the static network map to the dynamic flow of information. We need a way to measure the actual momentum of the retweet itself.
Okay, so how do we measure that momentum?
Dr. Chen applies something called the Galton-Watson branching process.
The Galton-Watson branching process.
Yeah. Historically, this model was used by scientists to study everything from the extinction of family surnames to nuclear chain reactions. But today, we mostly see it in epidemiology to track viral pandemics. The crucial metric in this model is the mean offspring number. It's usually denoted mathematically as M. In epidemiology, we call it R0.
Oh, R0. I think we all share some collective trauma from learning about that term during the pandemic, you know.
Right.
We've all seen the graphics. If R0 is 2, one person infects 2, who infect 4, who infect 8, it's a runaway train.
And that runaway train is what physicists call the supercritical regime, when your M value is greater than 1. Every event generates more than one subsequent event.
Yep.
If M is exactly 1, the cascade just replaces itself. But if M is less than 1, you enter the subcritical regime.
And what happens then?
The mathematical law here is absolute. If a virus or piece of information has an M value of less than 1, the transmission chain naturally starves. The cascade will inevitably go extinct.
And Dr. Chen actually went ahead and calculated his own M value for this specific retweet.
He did. He ran the exact parameters of his Edge Node account.
Let's hear the math.
So he had 100 followers. Based on standard platform analytics, maybe 15% of those followers were actually active online.
Okay, so that's 15 people.
Right. And the baseline probability of an active user seeing a piece of content and actually deciding to share it is generously around 1%.
Right, because most people just lurk.
Exactly. And crucially, because the content he forwarded was deemed sensitive, the platform's algorithms were actively suppressing it. So there was zero algorithmic amplification pushing it to strangers.
Zero. Okay, so if we do the math, 100 followers times 15% active times a 1% chance of them caring enough to hit share.
The calculation yields a mean offspring number, an M value, of exactly 0.12.
Wait, 0.12. So every post generates, on average, roughly 1/10 of a new post.
Yes. It's shrinking instantly. Because 0.12 is dramatically less than 1, he is trapped in what physicists call the deep subcritical regime.
Deep subcritical.
The extinction probability of his retweet, meaning the mathematical certainty that the chain of sharing will hit a dead end, is virtually 100%.
That's definitive.
You can even calculate the expected total size of the entire cascade using a simple formula. It's 1 divided by 1 minus M.
Let me do that in my head. 1 divided by 1 minus 0.12, that's 1 divided by 0.8.
Which comes out to roughly 1.11.
1.11. That is mind-blowing. The math dictates that his one initial retweet generates, on average, a tiny fraction of one additional retweet before the entire chain dies completely.
The physics of his specific network environment literally will not sustain a viral reaction.
It's like trying to start a raging, uncontrollable forest fire by dropping a single tiny spark into a damp, muddy swamp.
Exactly.
It doesn't matter how dangerous the spark is. The environment mathematically cannot catch fire.
And that mathematical proof exposes an astonishing legal discrepancy in this case.
What's the discrepancy?
Well, in the local judicial framework where Dr. Chen was charged, the threshold for a post causing serious chaos or severe disruption requires 500 retweets or 5,000 views.
500 retweets. and his calculated mathematically expected cascade size is 1.11.
The legal accusation misses the physical reality of the network by a factor of nearly 500.
What?
It is a difference in magnitude that makes the charge not just unlikely, but mathematically impossible. The prosecution is literally using the language of a supercritical explosion to describe a deep subcritical edge node.
But, okay, if Dr. Chen's math proves that his specific retweet died instantly in a muddy swamp, that leaves a massive elephant in the room.
What's that?
Real avalanches of public outrage do happen.
Yes, they do.
We see digital chaos, massive viral protest, and systemic disruptions online all the time. If edge nodes aren't starting them, where do they actually come from?
And to answer that, Dr. Chen pulls out his final and perhaps most profound scientific model. He introduces the theory of self-organized criticality, or SOC.
Self-organized criticality.
Yeah. This was developed by a theoretical physicist named Per Bach in 1987. Bach used a very intuitive model to explain how complex systems collapse. He called it the sand pile model.
Okay, picture a sand pile.
Imagine you have a flat table, and you are dropping sand onto it grain by grain. For a long time, nothing chaotic happens. A little pile forms. But as you continuously add sand, the sides of the pile get steeper and steeper. Eventually, the pile reaches a state where the slope cannot physically get any steeper without collapsing. Bach called this the critical state.
Meaning the system is now inherently dangerously unstable, like it's brimming with stored energy.
Exactly. When the sand pile is in this critical state, dropping just one more tiny grain of sand could do absolutely nothing. Or it could trigger a catastrophic avalanche that collapses the entire side of the pile. The system has naturally evolved or self-organized into a state of extreme fragility.
But wait, if the digital social sand pile is already highly unstable, say society's tense, the economy is rough, people are angry, couldn't the prosecution just pivot and say, AHA? Dr. Chen was that final grain of sand. He's the one who triggered the avalanche.
And that is the ultimate trap of linear legal thinking. And it is exactly where Dr. Chen executes a brilliant intellectual reversal.
How does he counter that?
Well, first, he points out a fatal flaw in the prosecution's evidence. To claim he triggered an avalanche, they first have to prove the sand pile was critical.
Oh, I see.
But they provided zero empirical evidence that the network was actually in a highly unstable state at the time of his retweet. They just assumed it was because it fit their narrative.
Right, you can't just look at a collapsed sand pile, point to a random grain of sand on the floor, and declare it the culprit without having measured the pile beforehand.
You can't. But his second point is the real philosophical knockout punch here.
Let's hear it.
He argues that if the system was indeed that unstable, if it truly was in a critical state where one tiny subcritical edge node retweet could theoretically bring down public order, then the fault lies entirely with the system itself, not the final grain of sand.
Because the pile was built too steep to begin with.
Precisely. And in a scale-free network, who has the power to build the sand pile that steep? The edge nodes don't have the gravity to do that.
Right, the environment is dominated by the hub nodes.
Exactly. Dr. Chen argues that the judicial authorities, the platform regulators, and state actors who are actual massive hub nodes with enormous systemic influence, they're the ones who inject entropy and systemic risk into the network.
So when these hubs engage in unjust actions or enforce rigid, unnatural marching band order on a system that naturally wants to be an open-air market, they're the ones piling the sand dangerously high.
They're the true source of the potential avalanches. From a complex systems perspective, attributing a systemic collapse to an edge node is fundamentally illogical.
It ignores the massive structural forces that actually govern the network's stability.
Blaming the edge node is just a convenient way for the hubs to avoid taking responsibility for the fragility they created themselves.
That is a stunning paradigm shift. He is effectively saying, don't blame the spark for the forest fire, blame the people who quietly soaked the entire forest in gasoline over the last 5 years.
It completely flips the narrative of responsibility. It uses physics to prove that systemic chaos is a top-down creation, not a bottom-up anomaly.
Wow. So what does this all mean for you listening to this deep dive? When we step back and look at the entirety of Dr. Chen's defense, it completely exposes a dangerous and widening gap.
A massive gap.
We have legal systems operating on linear 17th century Newtonian logic, where A pushes B and B falls over.
Right.
And they are trying to govern the nonlinear, almost quantum level reality of complex modern digital networks.
And this brings us right back to that quote from the Universal Declaration of Human Rights you mentioned at the very beginning of the show.
Oh, yeah?
All human beings are born free and equal in dignity and rights. True equality and dignity in the digital age require our legal systems to judge individuals by accurate scientific metrics.
Because if the system uses a broken scale to weigh your actions, your dignity is compromised before the trial even starts.
You cannot maintain human dignity if the law relies on subjective assumptions, outdated metaphors, and mathematical impossibilities to strip away someone's freedom.
Well said.
Dr. Chen's blood letter isn't just a personal defense against a local charge. It is a massive warning light, flashing over our entire global legal apparatus, pointing out a severe institutional scientific illiteracy.
Which leaves us with a deeply provocative final thought for you to ponder long after this deep dive ends.
Yeah.
We're moving into an era where algorithms are getting smarter by the second. Our networks are becoming infinitely more complex, entangled, and opaque.
It's only accelerating.
So how will our justice systems ever catch up to the math? If the law cannot even understand the basic physics of the platforms we use to communicate every single day, how can it ever fairly judge our actions on them?
Are we destined to be weighed on scales that were broken centuries ago?
Keep questioning the structures around you. The rules governing your digital life might just be built on a fundamental misunderstanding of reality itself. Thanks for taking the deep dive with us today.